Welcome to GCSE Maths Help. Today we're going to be looking at right-angled triangles exam paper questions. This video is a follow-on from my right-angled triangles key points video, which I will link in the bio below. If you haven't watched that video, you might find it useful before looking at exam questions. For everyone else, let's get started. So our first question says, the diagram shows the side view of a step ladder with a horizontal strut of length 48 centimetres. The strut is 1/3 of the way up the ladder. The symmetrical cross-section of the ladder shows two similar triangles. Work out the vertical height h centimetres of the ladder. So let's have a look at what the question's told us. The strut is 1/3 of the way up the ladder, and the ladder has a line of symmetry going down the middle. So because the question's told us this, we must need these bits of information to help us out. That's my top tip for maths questions, is that the examiner will never tell you anything that isn't needed somewhere in the question. Everything that's there is to help us. So let's have a think about how we can go about finding h. So this line of symmetry here, we'll draw that in, is going to be the same height as height h. So once we've drawn that in, we can see that we've got two right-angled triangles here. But we don't have enough information about these triangles to start working out h. So I'm going to draw the right angle a bit further up here. We've got a triangle here that we've got more information about. So because we've divided the strut in half, we've got a triangle that's 24 centimetres along the bottom. It's got the right angle, and we've got 2/3 of 141 centimetres for the length of our hypotenuse, because we've been told that the strut is 1/3 of the way up the ladder. That means that we can find 2/3 of the height of h. So using Pythagoras Theorem, we've got a squared is equal to b squared plus c squared. So 2/3 of 141 centimetres is 94 squared, is equal to our h squared plus 24 squared. So if we minus 24 squared from both sides, we've got 94 squared minus 24 squared is equal to h squared. So h squared is equal to 8,260. So h is equal to 90.9 centimetres. But if you remember, if we go back to our diagram, that h is only 2/3 of the overall height of the triangle, because we were looking at this smaller one. So we need to divide the 90.9 centimetres by 2 to find out 1/3, then times it by 3 to get the whole of h. So h is equal to 136.3 centimetres, which can pop down there as our answer. So this next question needs a little bit of thinking about. It says ABCDEF is a triangular prism which represents part of a hill. ABCF is the horizontal rectangular base. D is vertically above C. Work out the height of CD. So if we look at our diagram, we can see that there's a right angle in there. So we're going to be using one of our trigonometry ratios. So we've got an angle. We're interested in the length that's opposite it, and we've been given the length that's adjacent. So that's going to be our tan ratio. So we've got tan x is equal to opposite over adjacent. So let's fill in what we know. We've got tan 6 degrees is equal to CD, the length we're looking for, divided by 500 metres. So to get CD on its own, I'm going to times both sides by 500. So we've got 500 times tan 6 degrees is equal to CD. So 500 times, and then tan 6 degrees is 0.105 on our calculators, is equal to CD. So CD is equal to 52.6 metres. So far so good. Let's look at part B. So part B says Jamil walks in a straight line from A to D. Work out the size of angle DAC you must show you're working. So this is where we need to be really careful because the angle that we're looking for isn't already drawn on the diagram, so I've drawn it on. I've drawn the line where Jamil walks from A to D, and then I've highlighted the angle that we're looking for. It's angle DAC, so A is the point and it's enclosed by the line DA and AC. So you might be able to visualise the angle that you're looking for, but I find it's easier to draw it on and then you can be 100% sure. So the triangle that we're looking at is DCA. This is the angle that we're interested in. So we know the length of CD because we found that out in part A, so that's 52.6 metres. But we don't have any other information about this triangle. But if we go back to our original diagram, the length AC is the hypotenuse of another triangle, this triangle round here. And we've got all of the information to help us there. So if we draw that out here, we've got CBA, where AB is 400 metres and BC is 500 metres, and this is the length that we're looking for. So as you can see, we can use Pythagoras' theorem here. So we've got the length AC squared is equal to 400 metres squared plus 500 metres squared. So AC squared is equal to 410,000 on our calculator. So AC is equal to 640.3 metres. So now we can put that information onto our original triangle. We've got 640.3 metres here. So now we've got the length that's opposite the angle and the length that's adjacent to the angle. We can go about using one of our trigonometry rules. So if we've got opposite and adjacent, it's going to be tan. So tan x is equal to opposite over adjacent. So we want tan x is equal to 52.6 divided by 640.3. So using our calculator, tan x is equal to 0.0821. So the angle is equal to 4.7 degrees. So we can pop that down there as our answer. So like I say, it's really important that you're 100% sure exactly which angle that you're looking for because it wasn't drawn on the diagram, so make sure you're visualising the right angle with these kinds of questions. So as you can see from the question number, this was one of the ones at the end of the higher papers. So the likelihood is that it's going to be a difficult question and it's going to be an angle that isn't drawn on the paper. So just remember that when the angle is written out as 3 letters, the middle one is the point and the 2 letters either side make the lines that enclose the angle. So let's have another go at this type of question. This one says rectangle ABCD is the horizontal base of a triangular prism ABCDEF. AE equals BE. E is vertically above M, the midpoint of AB. AB equals 16 centimetres, AE equals 17 centimetres and BC equals 30 centimetres. Show that EM is equal to 15 centimetres. So let's have a think about what we know and draw it on the diagram. So AB is equal to 16 centimetres, AE is equal to 17 centimetres and BC is equal to 30 centimetres. So AE is equal to BE, so we've got an isosceles triangle here. So the last thing that we've been told is that E is above M, which is the midpoint of AB. So there's a right angle triangle drawn on our diagram, so I'm guessing that we're going to be using Pythagoras. So if we draw out our triangle, we've got E, M and A with a right angle in the middle. So we want to show that X here is 15 centimetres. So we know AE is 17 centimetres, we know AM is 8 centimetres because M is halfway between A and B. So we've got A squared is equal to B squared plus C squared. So 17 squared is equal to our X squared plus 8 squared. So we can do 289 is equal to x squared plus 64. So if we minus 64 from both sides, we've got 225 is equal to x squared. So x is equal to 15, which was what we were looking for, so that's good. So let's move on to part B because that gets a little bit more complicated. So part B says, work out the size of angle ECM. So again, this is one of these questions where the angle that we're looking for isn't actually drawn on the diagram. So you're going to have to either visualise it or draw it on like I've done. So angle ECM, C is the middle letter, so that's where the point is, and it's enclosed by lines EC and MC. So we'll draw out our new triangle that we're looking at here. So we've got the right angle, we've got E, M and C, and this is the angle that we're looking for. So let's have a think about what we know first. We know the length of EM from part A, that's 15 centimetres, and then we don't know anything about the other lines. So if we go back to the original diagram, CM is actually the hypotenuse of a new triangle now, this triangle here. And we've got more information about that triangle. So if we draw out this triangle here, we've got C, B and M. We've got MB is 8 centimetres because M is halfway between A and B. And BC is 30 centimetres, and this is the line that we're looking at finding. So we can see here that we can use Pythagoras. So A squared is equal to B squared plus C squared. So our x squared is equal to 30 squared plus 8 squared. So x squared is equal to 900 plus 64. So x squared is 964. So we'll square root both sides to give us 31 centimetres for x. So now we can pop that on our original diagram. So MC is equal to 31 centimetres. So now we've got the line that is opposite the angle and the line that's adjacent to the angle. So the ratio that we're going to be using is tan. So we've got tan x is equal to opposite over adjacent. So tan x is equal to 15 over 31. So tan x on our calculator is equal to 0.4823. So x is equal to 25.7 degrees. So I'm going to round that up to 26 degrees, which is our angle ECM. So if you don't know where to start with these questions, because they can be really overfacing, read through and see what it is that we know. Write on the diagram, write on what you've been told, and then hopefully you can see a way forward then towards the end goal. I really hope you found this video helpful. If you would like to have a little recap on the key points on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.